All right, today we're looking at lesson 7.1, which is adding and subtracting polynomials. Now, chapter 7 as a whole is a very important chapter because it's one of those skills. It teaches one of those skills that you're going to need for a very long time to come. Okay, Algebra 2, trigonometry. For those of you who are wanting to do dual enrollment, okay, and you want to take the PERT test and get into college math ahead of time, okay, factoring is very much a part of the PERT test. So this is one of those chapters that is super important. But before you can learn how to factor polynomials, you got to know what they are. You got to be able to break them apart and identify the different parts. So that's what we're focusing on today in 7.1. All right, so the essential question is, how can you add and subtract polynomials? Well, what is a polynomial? The first thing you're going to hear me refer to a lot today are terms. Okay, so what is a term? It's the parts of an expression that are being added or subtracted together. So when you see a problem and it's an addition problem, each part is a different term. All right, like terms. This is really important because this is the key to adding and subtracting polynomials. Like terms are terms with the same variable raised to the same power. Now, first of all, I want you to highlight everything in pink. I want you to highlight in your notes. But then within the definition of like terms, I would highlight same variable and same power. Because it's the same variable, it has to have the same variable, and it has to be raised to the same power. So that's very important when you're identifying like terms. Now, standard form. All of our answers today are going to be in standard form. So you have to know what that means. It means when exponents of the terms are in descending order from left to right. So when I'm looking at a problem, the term that has the largest exponent in it will be first, and the term that has the smallest exponent will be last. So we're looking at it, it should be in descending order from left to right. Now, a leading coefficient, this one has caused some struggle today, and I don't understand. There's two very important things. First of all, leading. If you were the line leader in elementary school, where were you standing? The front of the line. So when I'm looking at a polynomial and it's written in standard form, I'm going to the front of it, and I'm going to find the first number in front of the variable. So here's the key to understanding a leading coefficient. A coefficient is a number. It's not a variable. So within that definition, I would highlight first number, and maybe even just number. Whatever you got to do to remind yourself that a coefficient is not a variable, but it is a number. The first number at the front of your polynomial. Now, the degree. This one's either simple or a little hard to understand. When I'm looking at a problem, the largest exponent, whichever term has the largest exponent, that is the degree of my polynomial. But sometimes I'm looking at a problem and a term will have two variables in it with two exponents. So guess what? If a term has two exponents in it, I have to add them together to get the degree. So it's either the largest exponent or the largest sum of the exponents in a term. And we'll see an example here in just a couple minutes. Now, identifying polynomials by their terms. By definition, and this one actually took me a little time to really comprehend. Poly means many, right? So in my mind, a polynomial is anything with more than three terms. Because a one-term problem has a special name, a two-term problem has a special name, and a three-term. But look at the definition of a polynomial. It's actually a monomial. What does mono stand for? One. So it's actually even a monomial is considered a polynomial. It's a monomial or a sum of monomials. So look at the example I gave you. How many terms do you see in that example? Remember, terms are the parts being added together. So how many terms do you see in that example? 4, right? So that is a sum of monomials. So a polynomial by definition is a monomial or a sum of monomials. Now there are three special kinds. Monomial. Mono means what? One. So if a problem has one term, it's called a monomial. Bi means two. So if it has two terms, it's called a binomial. And tri means three. So if it's a trinomial, it has three terms. Anything with more than three terms, we would simply identify as a polynomial. All right? Any questions so far? Awesome. Now let's look at example 1. Find the degree of the monomial. If I look at each of these problems, A, B, and C, okay, why are they monomials? There's one term. None of them are being added or subtracted to anything else. So these are monomials. So looking at letter A, what is the degree of this monomial? If we find the largest exponent, there's only one of them, so the largest exponent is 4, which makes the degree of this monomial 4. Very good. Now look at letter B. How many exponents does this monomial have? So what am I going to have to do with them to find the degree? Add them. So 3 plus 2 is... So the degree of this monomial is what? Very good. So you see the difference between A and B when there's one exponent in the term versus when there are 2. All right, now look at letter C. This one's caused a little bit of debate today. Negative 20 and 5/10. What would you say, Emma, is the degree of this polynomial? Here's what I do. Look back at A and B. Where did we get the exponents that we used when naming the degree? Where were they located? What was their base? The variable. So if we look at letter C, is there a variable in letter C? So what do you think the degree of letter C is? 0. Very good. Letter C is what we call a constant. It has no variable with it, so it is called a constant. A constant, since there's no variable, has no degree. So if you're given a constant and asked for the degree, it is 0. Now let's look at example number 2. Let's highlight the things they're asking us to find, because they're asking us to find quite a bit. Write the polynomial in standard form. See, if I put this problem in standard form, then it's very easy for me to find all these different parts. It wants the degree, the leading coefficient, and then they want me to classify by the number of terms. Okay, but we got to put it in standard form first. So remember, I'm looking for the term with the highest exponent because I want it to be first. We're looking at these problems from left to right. What I also need you to remember and understand is every number and every variable has a sign, and the sign is directly in front of it. So when you start moving these things around, don't leave behind their signs. Make sure you take the right sign with the right term. All right, is there anybody brave enough to tell me what we would put first in letter A? What would need to be the first term? Which term has the largest exponent? Since the only term in this problem that has a variable is the second one, then that has to be my largest exponent, right? That z has an understood exponent of what? 1. All right? So, Abby, tell me again, what's going to be the first term as I start writing this in standard form?
9z.
Be careful. Every number has a sign. The sign's directly in front of it. So that's not 9z, that's what?
Oh, -9.
Negative 9z. So I got to make sure I bring the negative with the 9z. Now, that only leaves me with 4. What kind of 4 is that? Positive 4. So just by switching the two terms, I have it written in standard form. Largest exponent to smallest. Now, once it's in standard form, I should be able to identify these next 3 pieces very easily. What is the degree of this polynomial? 1, okay? The only exponent, the leading exponent, the first exponent is a 1. It's the biggest one we've got, so the degree is 1. All right, the next thing is the leading coefficient. What is the leading coefficient of this polynomial? Good. If I go to the front of it and I get that first number, it's -9. So the leading coefficient is -9. And lastly, I have to classify it. How many terms, Olivia, does this problem have?
2.
Which makes it a binomial. Very good. So we identify that it's a binomial. We're going to box in the rest of our answers, and you're done. Now, getting these answers is really simple if you know what you're looking for. So you've got to make sure you know the definitions. All right, look at letter B, standard form. We want it from the highest exponent down to the smallest exponent. So Noah, what would be our first term in letter B?
T to the third.
Okay, be very careful.
Negative t.
Negative t to the third. We got to take the right sign with the right term. So negative t to the third. Noah, keep going. What would be the next term in this problem?
T to the second.
Okay, but I need a sign. What kind of t squared is it?
Positive.
It's a positive, a plus t squared. And the last term would be?
Negative 10t.
Very good. Okay, a lot of people have struggled today with looking at the coefficients. They tried to tell me that negative 10t is the first term. But remember, I'm looking at the exponent. So I've got 3, 2, and 1. So we're in good shape. We're going to go ahead and box this in. That is standard form. Now, Claire, what is the degree then of this polynomial now that we have it in standard form? 3. The largest exponent in the problem is a 3, so that makes the degree a 3. All right. Alyssa, what is the leading coefficient of this problem? Very good. If I have t cubed and nothing in front of it, there is an understood 1 right there. So the leading coefficient of this problem is negative 1. Awesome job. And that leaves me with classifying it by terms. Gage, how many terms are in this problem?
3.
3? And so what kind of a polynomial is this?
Trinomial.
A trinomial. Very good. Go back. All right, box in the rest of your answers. And move on to letter C. All right, Esther, can you put it in standard form for me? We've got x cubed, that is the largest exponent in this problem, plus 2 and 8/10 x. All right, very good. So Esther, keep going. What is the degree of this problem? 3. And what is the leading coefficient of this problem? Go to the front of my problem. X cubed appears to have no coefficient, but there's an understood 1 there. So what is the leading coefficient, Esther? The leading coefficient is also 1. Very good. And how many terms are in this problem? Which makes it a binomial. Very good. All right. Now again, finding these answers is quick and simple if you know what you're looking for, if you know the definitions of these words. So make sure you spend some time memorizing and learning those definitions. Now, if we move on to example 3, this is where we get into adding and subtracting. You'll notice the fine print that you wrote down. You want to make sure, highlight it for me, okay? To add or subtract polynomials, you add or subtract the coefficients of like terms only. Now, I want you to notice 2 things. First of all it says to add are the coefficients. We don't do anything to the variable parts of these problems. We simply add or subtract the coefficients. We can only add or subtract coefficients, though, of like terms. Go back to your definitions if you need to, but somebody tell me, what are like terms? The same variable raised to the same power. So we're looking for these terms that have the same variable raised to the same power so that we can add their exponents. Okay, so we can add their coefficients. Now, look at letter A. If you look right in the center of the problem, you can tell me, is this an addition problem or subtraction problem?
Addition.
This is addition. So we go right into looking for our like terms. Remember, our final answer needs to be in standard form. So let's find a term with the largest exponent and work off of that. Okay, Olivia, which term has the largest exponent in letter A? All right, x squared. So the question is, does x squared have a like term? 7x squared also has the same variable raised to the same power. Now, x squared has an understood coefficient of what? X squared has an understood coefficient of what?
1.
1, because I need to add the coefficients. So, Olivia, what's 1 plus 7? So, what is 1x squared plus 7x squared going to give me? 8x squared. Because remember, I don't do anything to change the variable part. I simply add the coefficients together. All right, what's the next term in our answer going to be? The next term with the next largest exponent? Negative x. And does negative x have a like term?
Yes.
What is it? Negative x. And I'm going to go ahead and cross out the ones I've already used so I don't try to use them again. What are the understood coefficients of these negative x's?
1.
1. So negative 1x minus 1x is what, Gage? Good, negative 2x. Again, I simply add the coefficients and I keep the variable part the same. Cross it out. Now, what is the only thing left in this problem?
2.
Negative 2. And does it have a like term? So do I leave it? Do I bring it into my, what do I do with it? Bring it down. We always bring down what we have not used. And look at my final answer. It's in standard form. I've got x squared, x, and a constant. Now look at letter B. What type of problem is letter B? It is a subtraction problem. I want you to highlight the subtraction sign. And here's why. We can't go straight into combining like terms when it's a subtraction problem. So I want you to get used to identifying the type of problem it is so that you don't forget this important step. All right, so highlight it. Now again, there is an understood what behind that negative sign?
1.
A 1. And if there's a number in front of a parenthesis, what am I supposed to do with that number?
Multiply.
Give me the other word.
Distribute.
Distribute it. So technically, I am supposed to sit here and distribute negative 1. Negative 1 times negative 4p squared. Negative 1 times negative p, and negative 1 times 3. So I want this in your notes. I'm not saying that this has to be in your work later on, but I want it in your notes. All right? What happens when we take a negative and multiply it by a negative? We get a positive. A negative times a negative is a positive, and a negative times a positive is going to give me a negative. So, while yes, we are essentially distributing a negative 1, here's how we can pick the pace up just a little bit. Okay, I'm going to bring down the first set of parentheses exactly like it is. I don't do anything to the first set of parentheses, and actually I can drop the parentheses off. I don't need them, but I don't change anything about that first set. Now for my second set, because I recognize this is a subtraction problem, I'm going to go into the other set of parentheses and I'm simply going to change the sign of every term. So negative 4p squared is going to become positive 4p squared. Negative p is going to become positive p, and positive 3 is going to become, so I just go and change the sign of every term behind the negative sign. Now I can combine my like terms. So Noah, which term has the highest exponent? Because again, I want to start there.
P squared.
P squared, and does it have a like term?
4p squared.
4p squared. So when I combine those, I get what? Remembering, what's the understood coefficient of p squared?
1.
1. So 1p squared plus 4p squared is what?
5p squared.
5p squared. Awesome. Cross them out. Okay. Claire, what's the next set of terms I'm going to work with? P and p. What is the understood coefficient of those p's? No, don't combine them yet. What's the understood coefficient in front of each of them? 1 and 1. So what is 1p plus 1p? 2p's. Good. And do I have any other like terms? Luca? 3 and? Be careful. It's a 3 and a negative 3. All right? Good. A lot of times people think, no, I have no more like terms. But you learned how to add numbers together in elementary school, right? And if neither has a variable, then obviously they're alike. So what is negative 3 plus 3?
0.
Do I need that in my answer? No, I don't want it in my answer. So no, you can't put it. I don't want it. So 5p squared plus 2p would be your final answer. All right, let's look at letter C. What kind of a problem are we looking at? Subtraction. So once again, I want you to highlight that minus sign. You've got to get in the habit of identifying the type of problem before you just go straight into combining your like terms. So, do I do anything to change the first set of parentheses? No, I bring it down. I bring down negative k plus 5. What's going to happen to 3k squared? Negative 3k squared. And what's happening to negative 6? Positive 6. So again, if you need to fill in that understood one and you need to show that you're distributing it, please feel free. Whatever's going to help you remember to change those signs. Now, what term has the largest exponent in this problem? Negative 3k squared. Do we have any like terms for that? No. So we bring it down into our answer. What's the next largest exponent, Emma? Negative k. Do we have a like term for that one? Nope. So we bring it down into our answer. And then any other like terms, Abby, that I can combine? 5 and 6. And when we combine 5 and 6, we get what? Positive 11. So this is our final answer. Awesome. All right, now look at letter D. What kind of problem is it? Addition. So we go right into combining our like terms. Esther, what is our first set of terms that we want to work with? 4b and b. All right, what's the understood coefficient of b? 1. So when we combine 1b and 4b, we get what? 5b. Good. All right, our next set of terms, Gage, that we're going to look at? Negative 10. And when you combine negative 10 and negative 3, you get? Negative 13. All right. So there is your final. Again, it's standard form. Always make sure your answer is in standard form. But if you pick the right terms as you go, you're putting it in standard form as you go. All right. Any questions on these problems? Now let's open our books to page 363. And I want you to look at number 51. All right. If you're wondering why I did it this way, I did it for a couple reasons. Number one, I want you to be able to reference what page and what number this came from. So when you're studying, you can look back. Also, the instructions are a beast and the problem is a picture. So I wanted, there wasn't a point I was going to have you draw any of that. So we're just going to open our books to page 363 and we're going to look at number 51. Now look at the instructions. The polynomial negative 16t squared plus v sub o times t plus s sub o represents the height and feet of an object, where v sub o is the initial vertical velocity in feet per second, s sub o is the initial height of the object in feet, and t is the time in seconds. In exercise 51, write a polynomial that represents the height of the object, then find the height of the object after 1 second. So the first thing we're going to do is take in the directions, there's a formula. So we're going to write that down. It's negative 16t squared plus v sub o times t plus s sub o. Now, if you look at the picture on number 51, what does v sub o equal?
Negative 45.
Negative 45. So we're going to bring down negative 6t squared, or negative 16t squared, minus, in place of 45, we're plugging a negative 45. So in place of v sub o, we're plugging in the negative 45 times t. And then the picture again tells us what is the s sub o, or the initial height of the object. Positive 200. So in place of s sub o, we're plugging a 200. So this is the first part of the problem. We can box this in. This is part of our answer. This is the formula for the height of our object. Now, it wants to know how high our object is after 1 second. So where are we going to plug that number 1 into? In place of t, because t is our time. So negative 16 times 1 squared minus 45 times 1 plus 200. All right? What is 1 squared?
1.
And what is 1 times negative 16? And what is negative 45 times 1? Plus 200. Now, what is negative 16 minus 45? Negative 61 plus 200. What is negative 61 plus 200? 139. And this is a word problem, so what are the units, or what is the label for this problem?
Feet per second.
Is it feet per second or just feet? We already knew it was 1 second.
Feet.
So just feet. But again, you can take the information that you've learned and you can apply it in a word problem. All right? And it's not always difficult. But this is lesson 7.1.